Right, here's our third and last video in section 5.1. We've talked a lot about GCF, greatest common factor, in the last couple videos. We're going to add to that a little bit right now and talk about a factoring technique we called grouping. Remember, in our steps, if there are 4 terms, we're going to use the technique called grouping. So anytime I have a polynomial with 4 terms, we're going to use the technique called grouping. There's 3 steps. Step number 1 is you're going to draw a line to make 2 groups of 2 terms. You're going to separate into 2 groups of 2. Then you're going to factor out a GCF from each group. You're going to factor the binomial GCF after that. Let me show you what that means. Look at example number 3a. Now we're factoring, and so you remember the 7 steps in factoring. Step number 1 is always make sure that it's in order, which this one is, so that's good. Step number 2 is always look for a GCF first. Now, GCF means I have to be able to take it out of each term. And since there are 4 terms in this polynomial, is there a number that I can divide equally into 5 and -1 and 15 and 3? And we typically don't factor out a 1 because that doesn't change our polynomial much. So besides 1, I don't see a greatest common factor. And you notice that in this last term there is no x, so I can't even GCF out a variable. So it looks like there is no GCF in this problem. So step number 1, put it in order. We've done it. Step number 2, look for a GCF, and there isn't one. And so now we've got to figure out how many terms there are. You notice that there are 4 terms in this polynomial, so that tells us we're going to drop all the way down to step number 7, and we're going to factor with a method called grouping. In order to do grouping, we're going to draw a line, and we're going to separate our 4-term polynomial into 2 terms on each side. And then what we're going to do is we're going to look for a GCF in each group. So looking at this first group, what would be my GCF between 5x cubed and an x squared? Yeah, I took out an x squared. When I took out the x squared, I had a leftover 5x minus 1. Be careful, there's that -1 there, right? All right, my next step is I'm going to look for a GCF in my second group. So what number can I divide equally into 15 and 3? And then leave your leftovers. I ended up getting a +3, I can factor out a +3, and I have left over a 5x minus 1. Ooh, do you notice something? Do you notice that both of these terms have a 5x minus 1? That should always happen. If that doesn't happen, that's probably a clue you did something wrong. Your leftovers should match, and there should be a common factor again. And since both of my terms now have a 5x minus 1, I should be able to factor out a 5x minus 1 from each of those terms again. When I factor out a 5x minus 1 from each term, I have left over an x squared plus 3. And so this would be the factored version of my original problem. What I mean by that, if you were to FOIL that out, you would end up getting what you started with. You could always do that to double check. Let's do another one. Look at B. Factoring. So step number 1, is it in order from highest exponent to lowest? Yes. Step number 2, is there a GCF? Is there a number that I can take out of 2, 8, 1, and 4? Besides 1, because that won't change much. Can I take out an x from every single one of these terms? Well, the 4 doesn't have an x, so it doesn't look like there's a GCF on this one. So step number 3 is to look to see how many terms there are. Since there are 4 terms, I'm going to drop down to grouping. Let's try grouping again. Let's separate our 2 pieces, and let's look for a GCF in each piece. So what would be my GCF of 2x cubed plus 8x squared? And then leave your leftovers. I can take out a 2 and an x squared. When I do that, I have an x plus 4 left over. Again, you can always distribute through to double check if you want to. All right, what's the GCF in this group? This one's kind of tricky because I just got done saying we typically don't factor out a GCF of a 1. But if there's nothing else and we're doing the process of grouping, we have to have a GCF to take out. So we actually are going to factor out a 1 on this one. I'm going to factor out a 1, and so that I have leftovers of an x plus 4. Do you remember what I said about those leftovers, that they should always match? Which is perfect. Now they do. And since they match, we can take out an x plus 4 from each one, a greatest common factor. That means I have left over the 2x squared plus 1. So it's really important to factor out that GCF even if that GCF happens to be a 1 when you're grouping. So that way that you have this nice little binomial left over. So the factored version of my original problem would be an x plus 4 times a 2x squared plus 1. FOIL it out and double check. Make sure that you get the same answer that you started with. All right, let's do some more. All right, looking at C, if it asks us to factor, do you remember the first step in factoring? Make sure that you put it in order. If you just tried to go to grouping right away, you'd be stuck and you wouldn't have a GCF to take out, or your leftovers wouldn't match. So the very first thing that you should be doing always, 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 anytime we're factoring, is to put your polynomial in order. So rewriting it from highest exponent to lowest. Then let's look for a GCF. Is there a number you can divide into 4 and 20 and 3 and 15? I don't think so. Can you take out t's from every single term? Well, that 15 doesn't have a t, so it doesn't look like there's a GCF. So we've done step number 1, we've done step number 2. Our next thing is to look to see how many terms there are. It looks like there's 4 terms. That is my clue that we're going to do grouping. Let's draw our line and let's look at each little separate piece and look for a GCF in each of those pieces. On the left side, what GCF can I take out of 4 and 20? And what GCF can I take out of x cubed and x squared? I can take out a 4, or not, did I say x? I meant t, a 4t squared. I can take out a 4t squared. That would leave me with a t plus 5. All right, look at the next group. What GCF can I take out of a negative 3 and negative 15? Now be careful. Did you take out a negative 3? 1, because I want that first term to be positive. And 2, look at my leftovers now. If I take out a negative 3, if I divide by negative 3, I have left over a positive t and a positive 5 because negative 15 and negative 3 give me a positive 5, right? Now, since my leftovers match, I should be able to factor out GCF out again, a t plus 5. If I factor out a t plus 5, then that leaves me with a 4t squared minus 3 as my two binomial factors. A little bit different because that one had a GCF of a negative 3. All right, try D. Maybe pause the video and try D all by yourself and see how far you can get. All right, looking at D, if I'm following the steps of factoring, the first thing I want to do is put it in order. Did you see that? It's a little bit out of order. I want to put my negative 2t before my positive 10. Now that I have it in order, I can make my two groups and I can look for a GCF in each group. In this first group, I'm going to look for a GCF and it looks like I can take out a t to the 4th. If I take out a t to the 4th, I have a t minus 5 left over. All right, look at my second group. What do you think we're going to take out there as the GCF? All right, hopefully you took out a negative 2. If I take out a negative 2, I would have left over a t minus 5. Double check that real quick. What's negative 2 times t? Negative 2t, right? And what's negative times negative? Positive 10. So I can quickly double check that my leftovers match and are correct because I can FOIL it out. Plus, look at your leftovers now. Don't they match? And since they match, we can do our GCF again and take out that t minus 5. If I take out a t minus 5, then I have left over a t to the 4th minus 2. So this would be the factored version of my original problem. Ooh, let's do another one. All right. Is it in order? Is there a GCF? Ooh, did I get you on this one? This one has a GCF. What number can I take out of 2 and 6 and 4 and 12? Can I take out and divide everyone by 2? And look, all 4 of these terms at least have an x in it, don't they? And so I can actually factor out a GCF of a 2x. That's what you should be doing first before you do anything else. If you tried to group it, then you probably missed that GCF somewhere, and that GCF is really important if I'm asking you to factor, okay? So always put it in order first, always look for a GCF second, and then we can worry about what other type of factoring to do after those 2 steps. So if you take out a 2x, let's leave our leftovers. If I took out a 2x, I have left over an x cubed minus 3x squared plus 2x minus 6. And when we're factoring, we want to factor completely. We want to go as far down as possible. So just because I factored out a GCF doesn't mean I'm done factoring. I want you to look at this polynomial that's left over and see if we can factor some more. We've already taken out the GCF, and you notice that we have 1, 2, 3, 4 terms. So let's try to group it. Let's draw our line, let's look at each group, and let's see if we can factor out a GCF in each group. In the first one, it looks like I can take out an x squared, right? I took out an x squared, and that left me with an x minus 3. In my second group, it looks like I can take out a positive 2, and that left me with an x minus 3. Ooh, which is perfect, because now my leftovers match. I can GCF out that x minus 3, and I'm left with an x squared plus 2. Now don't forget, you had a GCF the 2x in the front, so that's part of your answer. You have your GCF from the beginning, and then you have your two factored binomials, your two factors of the 4-term polynomial that was left over. So you need to make sure that you have all 3 pieces as your final answer, your GCF and then your 2 binomials. What it would mean, and you could if you wanted to, if you had time on your test, is you could double check by foiling these 2 out, taking that answer and distributing the 2x through and seeing what you get. You should end up with what you started. It's a way to double check if you have time. All right, I would like you to try it. There are 5 problems here. So pause the video, take a few minutes, try each of these problems. They're all kind of mixed up, but this will give you a good idea if you're understanding not only GCF, greatest common factor, but also grouping, okay? Pause the video, come back to me, and see if you got the same answers that I did. All right, for the first one, it looks like it's in order. I took out a GCF of a 10, and that left me with an x plus 5. There's nothing else to factor out, nothing else I can simplify, so that looks like my final answer, just a GCF. On number 2, it's in order, and it does look like there's a GCF. Can I take out an x from both terms? When I take out an x, I have left over a 3x plus 1. If you forgot that 1, it would be incorrect, right? Because if I just had an x and a 3x and I tried to distribute or multiply, I would just have a 3x squared, and that does not match my original problem. So it's really important that you have that positive 1 so that if you were to go back through and distribute this, you should end up with what you started, a 3x squared plus x, which is perfect. So don't forget about that 1, okay? All right, let's look at number 3. I guess it's in order. It's kind of hard to tell with all the different letters, so hopefully it's in order. The next thing we're going to do is look for a GCF. So it looks like you can take out a 5, an a squared, and a b squared from every single one of these terms. If you take out a 5a squared b squared from every single one of these terms, what'd you get for your leftovers? I ended up getting a 7ab squared minus 2b plus 3a. And I can quickly double check by distributing that through and make sure that it matches my original problem. Hopefully you got the same answer that I did. All right, look at 4. Number 4 looks a little bit different, but be careful. I don't want to distribute or FOIL. I actually want to factor. I want to do the opposite. But what I did notice right off the bat is that both of these terms have a common factor. They have a b plus 5. So I'm going to GCF out that b plus 5, and that leaves me with a b minus 3. This would be the factored version of my original problem. And I'm done. I've already factored it. All right, look at number 5. Number 5 looks like it's in order. Number 5, is there a GCF besides a 1? I can't take out a z from everything, so it doesn't look like there's a GCF. And I notice that there are 4 terms, so this looks like it possibly is a grouping one. So let's divide it into 2 groups. Let's GCF out each group, and let's see what we got. In our first group, I took out a z squared. That left me with a z plus 3. In my second group, I took out a positive 7, and that left me with a z plus 3, which is perfect because now each one of my leftovers has a z plus 3, a common factor that I can take out, and then I'm left with a z squared plus 7. So this would be my final factored version of my original problem. Hopefully that's making sense to you. Make sure that you practice our greatest common factor and grouping because it's going to come up again with other different factoring techniques. So it's important that you get a good handle on the first section before we continue with some more factoring techniques. Let me know if you guys need anything.